Hello everyone, welcome to Chip Confessions. In our previous video, we saw about the string data type and till now we have completed the data types in Verilog. So we had to start with the coding and before that we should know about the building blocks which are used in coding. Means in today's session we will be seeing the different types of procedural blocks, and then in the next session we will be seeing different types of assignments. After these two sessions we will be directly heading with the coding in Verilog. So today we shall see about the different types of procedural blocks. Before that, I just forgot in string session that declaration of the string means whenever we have strings actually and which contains more than a single character. For a single character, basically we will take like 7 down to 0 as width. Usually we take like that. As 8-bit as a standard thing we will consider, even though the ASCII character takes 7 bits, means basic ASCII characters. But usually the standard ASCII characters, as it is expanded from 128 to 255 also, so it's better to take 7 down to 0, or means anything with a width of 8 bits. So we shall consider as 8 bits as a standard width for a ASCII character or any character with the ASCII value. What we have to do is, like for a single character we can give anything, like 7 down to 0 is good for a single character of string. But when we have multiple characters, what we have to do is we have to take reg, means we have to take the array of reg, and then in the width we have to mention something, and here we will be giving the name of the string. And whenever we are giving some value to the string, we should note the number of the characters. Like for example, if I am telling like Verilog is good, so if I say like that Verilog is good, it will be like we need to count the characters, that is 1 2 3 4 including the space, 5 6 7 8 9 10 11 12 13 14 and 15. So this width will be 15 star 8, that is 15 into 8 down to 0, or down to 1 also you can take, because anyhow we know the first character will always take 7 bits. So it's okay, down to 0 also we can give, or down to 1 also we can give. What we have to do is number of characters including the space multiplied with 8 down to 0, we have to give like this. We shall see the demonstration whenever we are coding. This is I missed in the previous session. I just wanted to tell about this. Okay, now we shall start procedural blocks, that is our today's topic. What is a procedural block? Before that, what is a procedure? In general meaning, procedure means something which happens in step to step. Like we should follow some procedure, or we should do something in step by step, we should do something systematically, like that it happens. It's procedure means whatever it is systematic or whatever it is step by step, means we know what we have to do one after the other. That is what procedure is. So what happens in a procedural block? The execution happens one after the other. Means if we are taking a procedural block, so this is a procedural block, means what is happening inside the block, whatever it is happening, that happens one after the other. For example, we have statement 1 here, we have statement 1 here, and then we have statement 2 here, and then we have statement 3 here, statement 4, like that. We'll be having multiple statements, like statement n. Till statement n we have n number of statements inside a procedural block. Means how it happens is, it will execute statement 1, and then it will go to statement 2, and then it will go to statement 3, then statement 4, then statement n. Means no matter whatever we have inside the procedural block, it will happen sequentially. Means if we have a block of code here, then after statement 4 this block executes, and then this next statement will execute. This block, it can be parallel block or sequential block of code, that we will see in our further classes. But as of now, what you have to understand about the procedural block is, whatever execution happens inside the procedural block, that will be one after the other as a procedure. Means this will be sequential. The word is sequential. The word is sequential. Sequential means one after the other the statements will execute. This can be a statement or this can be a block of code. No matter whatever it is in a procedural block, whatever we give or whatever the code we write inside, that will execute in a sequential way or one after the other. Okay. Now we understood what does a procedure or procedural block means. We shall see now what are the types of the procedural blocks in Verilog. We have majorly two types, that is, one is the always block and then is the initial block. We have always block and we have initial block. We shall see one by one. What is this always block? Always means what? Always means it is happening continuously. There is no end for this. So it means we are starting a simulation. This is start of simulation or start of execution, and once the code starts running, this always block will be running continuously until the end of the code. Means until the simulation terminates, this always block will be running. This is what always procedural block is. Means whenever there is a start of simulation, this always block will start at the beginning of the simulation. Whenever the simulation starts, this always block will start executing, and this always block will stop executing only at the end of the simulation. Okay, so what we have in this always block? This always block can contain a single statement. For a single statement, we do not need begin and end. For multiple statements, we need something called as begin and end. So in C or C++, what we have is, if we have some block or function, anything, we will do, this is the block of code, this is the starting of the block, we will have something like this. So we will enclose everything in between the curly braces in C or C++ or Java also. What happens in Verilog is, we have to use begin and end. There is no concept of curly braces for this procedural blocks, or any maximum blocks of code will be like begin and end only. Very rare cases you will be having this curly braces. Apart from that, maximum cases like 99% it will be begin and end only in Verilog and system Verilog. Okay, so always block, it can contain a single statement where begin and end is not required, or always block can contain multiple statements, there we need this begin and end. Okay. Okay, now for example, we are taking always and we have some variable called as a, and we will be assigning 0. So here what happens, this variable way will be always containing 0, means till the end of the simulation this a will be assigned with 0 only. That is what always is. Means it depends on the other codes also, it should not get conflicted with other values of a. Whenever you give here, it should not get conflicted with other values, but still as an example I am just giving. If you give always and for a single statement you are just taking some variable a and you are assigning with 0, means till the end of the simulation this a will be assigned with 0. That is what always block is. Once the simulation starts, this a will be assigned with a 0, and till the end of the simulation this A will be assigned with value 0 only. Okay. Now what we have, multiple statements. Multiple statements means we have to enclose it with begin and end, and if we give like A is equal to 0 and then we are waiting for some time, this is the delay actually that we will see in further classes. I'm just giving as an example. Again I am making some 1 and again I'm giving from delay, like that it is, means yes, like inside this block we can give anything. We can give, we are assigning some value here, and yes, like this whenever there are multiple statements you have to give begin and end. And whatever we mention after the hash, this will be considered as delay, means that many number of time units you are waiting, or that many number of time units you are waiting. If you are giving hash 2, you are waiting for 2 time units, and the time unit will depend on your simulation time. By default it is nanoseconds, and you can change it according to your design convenience. So whenever you are giving hash and you are giving some number, that will be taken as that many time units of delay, means you are assigning A is equal to 0 and then you are giving some hash 5 and then you are giving A is equal to 1. This means you are assigning you are assigning 0 to variable A and you are waiting for 5 time units. This hash 5 is nothing but 5 time units we are waiting, and then we are assigning 1 to A. So initially A will be 0 and after time units the value of A will be changed to 1 because we are assigning 1 to A. It is like that. So hash followed by the whatever the number will be considered as delay, and that many units the simulator will wait while executing, or the compiler will wait while executing. Okay, this is the thing. And now what we have to see is something called as sensitivity list. Sensitivity list. What is the sensitivity list? As the name itself says, sensitivity. Sensitivity means what? You are sensitive to something. For example, if someone has come, someone came to us, someone pinches at on our hand, what we will do? We'll just check what happened with our hand, right? Or if some mosquito comes and mosquito bites on our leg, hand, anywhere, cheeks or forehead, wherever the mosquito bites, we will just check what happened there, or we will hit. Literally I am hitting now. Okay, jokes apart, whenever something happens with our hand or with our legs, what we will do? We will just check what happened there. Sensitivity list is also like that only. Whenever we have something in our sensitivity list, whenever there is a change in that value to the variable we included in the sensitivity list, we will check what happened. That is what this sensitivity list is. So we have always block, and we use this sensitivity list with always block. Always block we have, and we have to use at here with the 2 brackets, that is not parenthesis, normal brackets. What we have to do is always at, and we have to use the parenthesis or normal brackets, and inside that we need to mention this sensitivity list. Inside this we need to mention this sensitivity list. Sensitivity list is nothing but the list of the variables the design is sensitive to. Means if there is one mosquito biting you, for example, one mosquito is biting on your hand, left hand, You will check whenever the mosquito bites, you will check your left hand. Whenever there is a mosquito biting on your right hand, you will check your right hand. When mosquitoes are biting both on your left hand and right hand, you will check both your left and right hands, right? So whenever we have sensitivity list, that is, we have in the sensitivity list, for example, in this code we will be in this design we shall consider we have variable A and variable B, and in always the sensitivity list we involve is we will take A and B. We will take, means whenever there are multiple variables, we will take by taking comma in between, and whenever there is a single variable we just take like this. Okay, there are two variables as I said in our design, that is we can consider edge A comma B. We have two variables, and whenever there is a change in these two variables, or whenever there is a change in one of these variables, this will be executed. Means the always block will be executed whenever there is a change in one of these variables or both of the variables. So sensitivity list will work as a control to the always block. Just imagine there is no control to the always block. As I said before, always A is equal to 0 I gave. Like I gave always A is equal to 0. This doesn't have any control. Means till the end of the simulation, starting from the beginning of the simulation, what happens is A will be assigned with 0 only always. There is no control to this. But what happens here is the sensitivity list will act as a control to the always block. Means this always block, even though it is executed till the end of the simulation, there is a choice of execution. Means whenever there is a change in one of these variables we included inside what is so called as sensitivity list, then only this always block will be executed. Otherwise this always block will not get executed when there is no change in either of the variables. Okay, means we have A and B, and some code we will write. A is equal to 0, B is equal to something, not 0 actually. A is equal to, we shall say A and B. This is how we are writing. Okay, some random code I just written. A and B, this AND is nothing but your AND gate. Okay, AND gate you know already, you might have learned in your digital electronics, that we will cover anyhow. So A and B, something we are writing, we are just writing some AND code, or we shall say something A plus B. So this addition will be assigned to variable A. So whenever there is a change in one of the variables or both of the variables, then only this will happen. Usually we will take output here, say some y is equal to A plus B. So this makes some sense, that A is equal to A plus B will not make sense. So this will make some sense. So y is the output. Y is the output here. So we have three variables A, B and Y, where A and B are inputs and Y is the output. And what we are doing here is we are checking from beginning of the simulation till the end of the simulation. We will be seeing whether there is a change in any of the variables, and whenever there is a change we'll just enter into this block and we are executing this code. This is what always block is. Always means this block will execute from the beginning of the simulation till the end of the simulation, and whenever we have a single statement we need not to use begin and end, and whenever we have multiple statements we have to use begin and end, and in between that begin and end we have to give the, or we have to write the executable statements, that is the multiple statements we have. And always block has something called a sensitivity list, which acts as a control to that always block, and whenever there is a change in the variables we included in that sensitivity list, the code inside this always block will get executed. Otherwise this block will not get executed. And always block, as I said, sequential execution will happen. Means inside the always block we have statement 1, next statement 2, statement 3, statement 4, like that. No matter how many statements we have, everything will be executed in a sequential way. Means until and unless the statement 1 executes, statement 2 will not get executed. and until and unless statement 2 is executed, statement 3 will not get executed. Like that, one after the other. After the completion of one statement only, these statements will get executed. Okay, this is about the always block. Then we will see about initial block now. Okay, now we shall see about the initial block. And initial block, as the name itself says, it is one of the procedural blocks, and as the name itself says, initial means beginning. This initial block will get executed at the beginning of the simulation. Okay, then you can ask me, always also executes at the beginning of the simulation, then why we have both? Yes, the difference is always means it will get executed always till the end of the simulation. Means once the execution of always starts, that will continue till the end of the simulation. But this initial block, once it executes, it is done. This initial block will not execute it again and again. Initial block means at the initial stage of the simulation, that is the beginning of the simulation, this block will get executed, and this block will be executed only once. Means always block will be revisited till the end of the simulation whenever there is a changes in the sensitivity, there is a change in the value of the variable we included inside the sensitivity list, or if there is no sensitivity list, directly always will be executed always till the end of the simulation. But initial block, once it is executed, it is done. Consider an analogy. You will go to your home, somewhere you have gone outside and you will go back to your home, and at your home what happens? At your home you will go and you will be having a main door. Okay, main door. What you will do? Main door, there will be a lock, there will be a lock here, and you have to open the main door. Initial block is like opening the main door of the home. How many times you will open the main door? You will open the main door, you will go inside, will you come outside, again lock, again open, come outside, again lock, again open? Will you do that? No, right? So this initial block is like opening the main door of your home. Once if you open, you get inside, that is done. Until you come back or you go outside, then you lock and you will go. That is called end of the simulation. Means the beginning of the simulation is nothing but entering your home. Okay, entering your home, you will enter the home, you will open the lock of your main door and you will go inside, and once you are done with that, you will not repeat that work until and unless you go out again, right? So initial block is like your main door lock opening. Once it is done, it is done. So initial block is the procedural block that will get executed at the beginning of your execution, and it will not get repeated or revisited again till the end of the simulation. Okay, and what we do in this initial block, we saw in always block, we will be doing some code or we will be modeling the hardware. Means your actual design will happen inside the always block maximum times. Means what happens is, this we have in our initial videos or initial sessions, I told you something called as simulation and synthesizing. Always block is synthesizable. Means no matter whatever you do or whatever the code you write inside your always block will get synthesized into design or synthesized into hardware. But initial block is non-synthesizable. It is just used to initialize any values that you have to give to your variables. Where we will give the values to the variables, usually we will do that in the test bench. So in your design code, usually you will not assign any values to your variables or input variables or output variables. You will not assign any values. You will just write the design in a general way so that it can take any values, and based on that values it will process or it will calculate and it will give the result. What happens in test bench is you need to assign some values. So for assigning some values, we will use this initial block. Means at the initial stage of the simulation, whenever you are initializing or whenever you are assigning the value for the first time or assigning the variable value for the first time, at that time this initial block is used. So initial block is non-synthesizable and majorly it is used in the test bench to give values or to assign values to the variables. So the structure is initial, and whenever you have a single statement, begin and end is not required, and whenever you have a statement, multiple statements, you need to use initial, begin and end, and in between this you have to give the statements, like you can give statement 1 and you have to give statement 1, statement 2, statement 3, statement 4, like this. Okay, in the initial block, whenever we have multiple statements, we have to give begin and end, and we can give any number of statements in between. And these statements also will happen, or the execution will happen in a sequential way or one after the other. Okay, anywhere one thing is where this begin and end will come, that begin and end will tell whatever the statements inside this begin and end will happen in a sequential way or will execute one after the other, means it is called as blocking. Sequential is nothing but you are blocking, because whenever there is a statement 1, whenever we are executing statement 1, that will block the execution of statement 2. Until and unless the statement 1 get executed, statement 2 will not get executed. That is called as blocking. We will see this in our further sessions. So you just need to understand, inside this begin and end, the statements will execute in a sequential way, that is one after the other. So this is what initial and always blocks are about. And whenever you are giving, for example, in a code, we have module and name of the module and some end module we will give, and in between this you can declare anything. Okay, you can declare anything, but whenever you are assigning some values inside the procedural block, you, apart from continuous assignment that we will discuss further, whenever you are doing a procedural assignment, that must happen inside this procedural block only. For example, you have taken reg A, and if you just give A is equal to 5, this will throw an error. Or you want to give any delays, a hash file like this will give you an error. What you have to do is, you have to take an initial block or an always block based on the application, and then you have to give the statements or write the statements inside this block. So these two blocks are very important, means these two blocks, I can say, the basic blocks inside the module you use whenever you are assigning any values. This is called procedural assignment. Whatever we do inside the procedural block, the value assignment we do, that is called as procedural assignment. Another one is there which is called as continuous assignment, that we will see in our next session. So this is called as procedural assignment, and to do this block or initial block or always block is very important. If we do not use that, definitely you will get an error. Okay, why this is, this is how the syntax of Verilog is. This is the syntax of the Verilog, and we have to follow it. You need to be a Roman in Rome, Indian in India. Yes, Indian in India, why not that proverb? Okay, fine. Okay, this is what we learned today. And one more thing, whenever we can use as many as always blocks as many as initial blocks in your module or in your code, and this will happen simultaneously. For example, we have a module and end module, and in between this module you can have always, and we can say this is the first always block, and this is the second always block, we'll say here in between we have an initial first block, and we have initial second block, and somewhere we have here initial third block or initial nth block, or we have something always nth block. If we have like this, what happens is at 0 time, means at the beginning of the simulation, all this will start simultaneously. All this will start simultaneously, means at time 0 always 1 will start, initial 1 will start, initial 2 will start, means whatever the always or initial block you have in your code, everything will execute, or everything will start executing at the 0 time only. So you have to understand that you can include any number of initial or always blocks, and these blocks will start executing. All the blocks execute parallelly, but inside this block, in between this begin and end, everything will happen sequentially. That we have to understand. Okay, so this is for today's video. We learned about the procedural blocks, that is two types, initial and always block. I hope you understood. If you have any doubts, you can put in the comment box so that I can address it in our next session. And in our next session, we will be seeing about the procedural and continuous assignments, and after that we will be heading directly towards the coding. So we will take up a design, means design at the digital level, and then we will convert the same into the code level. So thank you for being with me, and please like, share this video and subscribe to my channel so that you will not miss any updates in the future. Thank you so much. Thank you. Have a great day.